All right. So in order to be able to succeed with factoring, and there's a lot of stuff involved with factoring, but one of the things you got to be able to do is these skills from last semester. So one of them is this. Suppose you want to multiply. Let's say number one, it was 5 times 2x squared minus 3x plus 4. So 5 times 2x squared minus 3x plus 4. Do you remember what you did to multiply that? Distributive property. Use the distributive property. So basically what you have here is inside the parentheses, how many terms do you see? 3. So that was called a trinomial. Remember that, a trinomial? A trinomial. On the outside, you only see one factor, one term, right? 5. So when it's just one term, we call it a monomial. So whenever you have a polynomial, poly means more than one or more terms, one or more monomials, multiplied by monomial, you just use the distributive property. Okay? So you would say 5 times 2x squared is 10x squared. 5 times a negative 3x is negative 15x. And then 5 times 4 is positive 20. Okay? And we tend to put it in descending order. Descending order. And so descending order means put the term that has the largest exponent first, then the next lowest, and so on. We always put the constant last. This is your constant. The 20 is called the constant because there's no variable there, meaning that's always going to be 20. So this is in descending order. Exponent 2, exponent 1, and then your constant. All right. Now before we do number 2, let's kind of review something else. So if I have x to the 5th power, x to the 5th power, you all know that 5 is the exponent. But what is x called? And don't say variable. The base. The base. So x is the base. So that's your base and that's your exponent, right? So if I had x to the 5th times x to the 3rd, let's say, x to the 5th times x to the 3rd. Do you remember how else this is written as? Whenever, okay, so remember last semester you talked about the product rule. The product rule. And so basically it said this, that when you multiply like bases, you do what to those exponents? You add them. When you multiply like bases, you add exponents. So x to the 5th times x to the 3rd is x to what power? 8. The 8th. Okay? X to the 8th. So we multiply like base, you add exponents. It kind of makes sense. It kind of makes sense that that's what's happening because in x to the 5th, isn't x to the 5th the same thing as x times x times x times x times x? Mm-hmm. And isn't x cubed the same thing as x times x times x? Mm-hmm. So how many factors of x are being multiplied together? 8. So x to the 8th. All right, now let's use that idea with number 2. In number 2, suppose you had x cubed times 2x squared minus 6x minus 5. So x cubed times 2x squared minus 6x minus 5. So if I want to multiply this out, first of all, do I have a monomial on the outside? Yes. So I can use what property? Distributive property. All right, so I have x cubed times 2x squared. So let's think about this. This is x cubed times x squared, right? So what's x cubed times x squared? X to the 5th. So what is x cubed times 2x squared? 2x to the 5th. That's 2x to the 5th. What is x cubed times a negative 6x?
Negative 6 to the 4th.
To the 4th. Because remember, x cubed times x, if there's no exponent, it's understood to be a 1. So 3 plus 1 is 4. So that'll be minus 6x to the 4th. And then what is x cubed times a negative 5? Negative 5x cubed. And that's all you can do. Now, this is important because when we start factoring Tuesday, when we start factoring, one of the things you're going to talk about is the GCF, the greatest common factor. And you're going to factor out the greatest common factor, and it's going to involve this idea. So it's like reverse distributive property, so to speak. All right, number 3. All right, 3, suppose you have 3xy times 5xy squared minus 7y plus 2x. So 3xy times 5xy squared minus 7y plus 2x. So what property are you going to use? Distributive property. All right, let's do the coefficients first. What's 3 times 5? 15. All right, now let's deal with the variables. I have xy times xy squared, right? So again, remember, when you multiply like base, you add exponents. So x times x is x squared. Y times y squared is y cubed. So 3xy times 5xy squared is 15 what? X squared y cubed. All right. What is 3 times negative 7? Negative 21. All right, let's do the variables. What is xy times y? Xy squared. You'll agree? Okay. So that'll be minus 21 xy squared. What is 3 times 2? 6. So I have xy times x, which is what?
X squared y.
So that's 6x squared y. All right. And remember, those are not like terms. Remember, let's talk about like terms. We used the word like terms last semester. Like terms are terms that have the same variables raised to the same power. So they all have x's in it, right? And they'll have y's in it. But look at the x's. This is 2. This has exponent 1. This has exponent 2. This is y cubed, y squared, y. Do any term have the same variable raised to the same power? No. They don't. They're all different. They all have xy's, but there's not two of them. Like, let's say this. Let's say this was x squared y cubed and this was x squared y cubed. Would they then be alike? Yes. Okay. All right. So you can't do anything here, so you're done. 4. Suppose I had 8v squared times u squared plus 2uv minus 6v cubed. So 8v squared times u squared plus 2uv minus 6v cubed. All right, same idea. You're going to use the distributive property. So what is 8v squared times u squared? And let's put it. Let's put them in alphabetical order. So let's put the u first. It'll be 8 what? U squared v squared. All right. Now it doesn't matter. You could have said 8v squared u squared. It does not matter. But we tend to put it in alphabetical order. All right. What is 8 times 2? 16, right? All right, now we have v squared times uv. And let's put it in alphabetical order. So it'll be uv cubed, right? Because v squared times v is v cubed. So this is 16uv cubed. All right, what's 8 times a negative 6?
-48.
Okay, so we have v squared times v cubed, which is v to the 5th. No, nothing alike terms, so you're done. So that's number 4. All right, let's go to number 5. All right, number 5. Suppose number 5, I have this. Six x cubed y to the 4th times x squared minus 3xy plus 5y. So 6x cubed y to the 4th times x squared minus 3xy plus 5y. So again, to multiply this, what property are you going to use? Distributive property. So 6x cubed y to the 4th times x squared. So that's going to be a 6 so far, right? All right, let's figure out what x cubed y to the 4th times x squared is. What do you think it is?
6x.
6 to the 5th.
X to the 5th, y to the 4th, right? Because we multiply like base, you add exponents. X cubed times x squared is x to the 5th. So this becomes 6 x to the 5th, y to the 4th. All right, now what is 6 times a negative 3? Okay, now what is x cubed y to the 4th times x y? What's that? X to the 4th,
Y to the 5th.
y to the 5th. Y'all agree? Okay, so that'll be minus 18, x to the 4th, y to the 5th. And then 6 times 5 is 30. So I have x cubed y to the 4th times y. So this time what's that equal to?
X to the 3rd, Y to the 5th.
Y to the 5th. So plus 30, x cubed, y to the 5th. All right, so that's your answer there. Number 6. So in 6, suppose you had negative 5 m cubed into the 5th times 3 m n squared minus 6 m cubed n plus 3n minus 5. Now, at some point, you should be able to do this pretty quickly. You don't have to write all that stuff that I'm writing. But you just got to be careful. So a negative 5 times 3 is negative 15. All right, let's talk about the variables now. I have m cubed into the 5th times m n squared. So what's m cubed times m? In the 4th. So remember, you're using a product rule. When you multiply like bases, you add exponents. 3 plus 1 is 4. What's m squared times into the 5th times n squared? Into the 7th. So this is negative 15, m to the 4th, into the 7th. What's a negative 5 times a negative 6? Positive 30. All right, so now I have m cubed into the 5th times m cubed n. So m to the 6, right? N to the 6. So that's 30 m to the 6 n to the 6. What's a negative 5 times 3? Negative 15. All right, so I have m cubed into the 5th times n. What is it? That's m cubed into the 6. What's a negative 5 times a negative 5? Positive 25. So what's a negative 5 m cubed into the 5th times a negative 5? Yeah, It's just m cubed into the fifth. And so that's your answer. All right, but then you also did this last semester. Five x minus 2 times x plus 3. You did that last semester. So if you look at the previous 6 problems, what property did you use? No, the previous 6. Distributive property. Use distributive property. In number 7, you don't have a monomial times a polynomial. It's not written like the others. What you have here is a binomial times a binomial. So remember, when you have a binomial times a binomial, what's the best way to multiply binomial times a binomial? FOIL. F-O-I-L. Remember that? F-O-I-L? FOIL? Now, the FOIL method does involve the distributive property. Yes.
I don't understand what the FOIL is.
Well, we're about to talk about it. All right. So the distributive property, it does involve the distributive property because basically what's happening is everything in here is multiplied by 5x and everything in here is multiplied by -2. That's really what's happening here. But FOIL, remember, what does the F stand for? First. What does the O stand for? Outer. The I? Inner. And the L? Last. So first, outer, inner, last. So basically, remember what the F stands for. The F says I take the first term of each binomial. The first term of each binomial. And remember, what's that operation right here that I'm pointing to? Multiplication. So I take the first term here, the first term here. Remember those little arcs that you drew? This little arc? There were 4 of them that you drew. So first times first is what? 5x squared. The outer says that if you look at those 4 terms in that order right here, the terms on the outside are these. These are the terms that are on the what? Inside. Okay. So these are your outside terms. So outer, outside terms. So what's 5x times 3? 15x, right? Okay. I means the terms on the inside. What is the product of those 2 terms? Negative 2x. And L is the same idea as F. F, remember, was the first terms of each binomial. You multiply them. The L is the last terms of each binomial. So that's -2 times a +3, which is a -6. So that's FOIL. That's the FOIL. How many terms do you see? 4. Can you combine any of them? Yes. You can combine the 2 middle ones, right? Because what is 15x and a -2x? 13x. So let's put in descending order. So what's the answer?
5x squared plus 13x minus 6.
Y'all agree? Okay, so that's the FOIL method. All right, let's add 8. And 8, suppose you had this. Suppose in 8 you had 3x plus 5y times 2x minus y. So there will be instances in this course where when you factor, you're going to have 2 variables, just like you see here. All right. So let's do the FOIL method. I can use a FOIL. Why can't I use a FOIL here? Because I'm multiplying 2 binomials. So let's do FOIL. So first means I take the first terms of each binomial, just like this. What's 3x times 2x? 6x squared. The outer means the terms on the outside terms. So what's 3x times a -y? Y'all agree? Okay. The inner means the terms on the inside. What's 5y times 2x? 10xy. And then the last means the terms on the last terms of each binomial. So what's 5y times -y? Okay, so that's where I'm at. Kind of combining things. Yeah, the two middle. So what's a negative 3xy and a positive 10xy? So that'll be 7xy. So I get 6x squared plus 7xy minus 5y squared. Okay? All method. Number 9. All right, number 9. We have 2 left. So it's number 9. 5x minus 2 squared. 5x minus 2 squared. So this time I'm squaring this binomial. What'd y'all do?
You just write it again.
Yeah, so remember, if you kind of think about this number 8 squared. 8 squared means 8 times 8, right? So that's 8 times. So therefore, 5x minus 2 squared means 5x minus 2 times itself. And then you use what method? FOIL. You use FOIL. So what's 5x times 5x? What's the outer?
10x.
Negative 10x, right? What's the inner? Negative 10x. In fact, since you're squaring a binomial, if you may not remember this, but what happens is that when you square a binomial, the outer and the inner are alike. So notice, are the outer and the inner the same thing? Yeah. What is the last? Positive 4. And when you combine like terms, what do you end up with? What's your answer? 25x squared, huh? Minus 20x. Because a negative 10 and a negative 10 is a, negative 20. And then plus 4. A negative times a negative is a positive, but I'm not multiplying, I'm adding. Okay? And then finally, number 10. Suppose we had this. 8m minus 3n squared. 8m minus 3n squared. What do you do? First of all, you're going to do what? Rewrite it. Rewrite it to binomials. So that's going to be 8m minus 3n times itself, right? And now we do what method? FOIL. So what's 8m times 8m? 64m squared. Now remember, I'm squaring a binomial, so when I do the outer and inner, they better be identical. What is the outer? Y'all agree? Negative 24mn. The inner better be the same thing, so let's check it though. What's the negative 3n times 8m? Yep, so the same thing. And now the last. What's a negative 3n times a negative 3n? Positive 9n squared. And so what's your final answer?
64n squared minus 48n.
Yeah, so a negative 24 and a negative 24 is a negative 48. So negative 48mn and then plus 9n squared. Okay? All right. So that's going to be needed for factoring. So that was a review that you really need to know to do factoring. Because what's going to happen, you see when we FOIL these, when you factor, many times you're going to use reverse FOIL. And you can see how that's going to work, reverse FOIL. Okay? All right. So